We're going to look at three normal distribution questions. The first one is we have IQ data, and we want to figure out what is the cutoff for the top 15% of people taking the IQ test. So we draw our familiar normal curve with a mean of 100, standard deviation of 15, and we're looking at the top 15%. So what we have to do is figure out what the score is. To do this, we start with the z calculation. Z equals the score minus the mean over the standard deviation. And in this particular case, we look up, we know the score, we know the mean, which is 100. We know the standard deviation, which is 15. We have to look up the z-score that corresponds with the top 15%. Now, it's important for us to realize that if this is the top 15%, that 85% is below this number. So 85% is over here. So we're going to go to the table and look up 0.8500 in the table. We look at the two tables that are available. One sort of goes on the left side of the mean. The other sort of goes on the right side of the mean. Since we're dealing with the top 15%, we're going to get this second chart. And if we look for 8.5 on this chart, we find that it is actually at 1.04 units. So you read the left side 1.0, you go across until you find 0.85. So we're looking, this is the probability, this is the area under the curve, and we're looking for 0.850. We find it right here, and then we read up and find that that's 1.04. So we use 1.04 for the z. Okay, and then we have to solve this equation. We multiply both sides by 15, and this becomes 15.60 equals x minus 100. And then we add 100 to both sides. And so we get 115, which we were hoping to find that it would be bigger than 100, because 100 is the mean. So the score at which we have the cutoff for the top 15% would be 115.60. Our second question is, okay, that worked great on that side. Let's see, what is the cutoff for the bottom 10%? So again, we draw our curve. We notice on this time we're at the bottom 10%. So we're all the way to the left. That tells us which chart we're going to use. Again, we're looking for the score. Again, the mean is 100, since it's IQ data, and 15 is the standard deviation. We go back to the same z formula, but now we use a different table. Let's fill in what we know. We know that the mean is 100 and the standard deviation is 15. Now we've got to find the right z. I'm not going to use this table, but actually this one, because it's all the way in the left tail. And I'm looking for the value of 0.10, and it's 10%, and when I look at it carefully, I read across, it's hard for you guys to see this, but this is negative 1.28. So this is negative 1.28. Notice it's negative when we're to the left of the mean. I'm going to solve this, multiply it out. This is negative 19.20 equals x minus 100. Now when I add 100 to both sides, I'm actually going to get a number less than 100. Since this is a negative number, I get 80.8 equals the score for the bottom 10. So this is 80.8, which makes sense. It's less than 100. This was 115.60, which makes sense. It's more than 100. So we have our third question, and that question is, okay, we've got new data here. It's an SAT problem. Okay, so we have SAT data, and we have 600 students. How many should score above a score of 480? So So I'm going to draw it again. I know that the mean for SAT is 500, standard deviation is 100, and we're at 480, which is pretty close to 500. Okay, so we would guess right off the jump, if we wanted to know how many were more than 480, we would guess a little bit more than 50%. We don't know exactly how much more. We're going to calculate that in just a second. Again, we start off with a z calculation. We know that the score this time is 480. The mean is 500, and the standard deviation is 100. When I calculate this, I get minus 20 over 100. That gives me a z value. In this case, we're calculating the z because we already know the score. Okay, and that comes out to negative 0.20. I go to the table now, and I'm going to use it in exactly reverse. Notice we're still to the left of the mean, so we're going to use to the left of the mean here. And what I'm going to look up is a z of negative 0.20. So 0.0 is here, 0.1 is here, 0.20 is right here. So the number I get, if I look real carefully, the number I get is 0.4207. So that is the percentage of the graph that's to the left of this point, which is a nice number, but it's not what we're looking for. We're actually looking for the percentage to the right, the number of people to the right. So I would subtract this from 1 to find out, since all of this adds up to 100% or 1, so I'm going to find out what is left on this side. Since there's 0.4207 on this side, the rest of it is on this side. When I subtract this, I get 0.5793. That's the percentage to the right, or the decimal equivalent. Okay, and then I want to take that number and multiply it by 600, and I get 347.58. I'm going to round that up and call it 348 students. 348 students. Okay, so those are 3 problems from normal distributions using the z-tables.